Before I proceed, let me first offer a sincere thanks to those of you who have subscribed. I realize many of you YouTubers may laugh at me for cherishing my 88 subscriptions, but to me, each subscription is a bar of gold. It tells me there are still some free and independent thinkers out there who are willing to consider some new mathematics. It tells me that there are still a few brave souls who have decided to join me on this math journey, and that so far they have been satisfied with my work. And so once again I say thank you, and thank you. I promised you new, exciting, groundbreaking discoveries in mathematics. And so far I think I have kept my promise. I have given you ironclad, irrefutable proofs of the Riemann Hypothesis, the Biot conjecture, and the Cauchy's conjecture. I have given you a formal algebraic proof of the fundamental theorem of algebra and the fundamental theorem of calculus. I have proven the negation of Fermat's last theorem, discovered a whole new system of Pythagorean triples based upon Euclid's formula, and given proof of an alternative solution to the infinite summation of the integers. And last but not least, all of this was done by using the principles of this new and revolutionary system of differential and integral calculus called Quick. And guess what? We have just barely scratched the surface. Quick is certainly broad enough and diverse enough to stand alone as a discipline of pure mathematics. It has excelled in uncovering new discoveries in the field of number theory, but Quick becomes so much more rich and useful as applied mathematics, particularly when applied to physics. And so it is here that we will shift from the theoretical aspects of Quick and transition over to the more practical applications of Quick. In establishing the rudimentary principles of Quick, I concentrated on proving long-standing mathematical conjectures to demonstrate the power and versatility of Quick, and I will continue to follow this practice. The Millennium Prize problems are 7 mathematical problems selected by the Clay Mathematics Institute. The Institute will award $1 million to anyone who can solve any of the 7 problems. One of those problems was the Riemann hypothesis. This I solved simply and elegantly by using the rudimentary rules and principles of Quick. The solution was obtained by using the more theoretical and pure mathematics aspects of Quick. The next Millennium Prize problem I'll solve will be one of our first physics conjectures. That problem will be the Navier-Stokes problem, and I will solve it using Quick as an applied mathematics application. However, for right now, I'm asking you to be patient. We will tackle the Navier-Stokes problem in a future video. But before we can even think about tackling the Navier-Stokes problem, I have to first establish several rudimentary principles of physics. We have to slowly familiarize ourselves with the Quickian interpretation of basic physics. This Quickian interpretation is called Quaternion Mechanics and is abbreviated as QM. Just as Quick does not conflict with Newtonian calculus on a practical level, neither does Quick conflict with classical physics on a practical level. Now, what is classical physics? Classical physics is causal physics, a science based upon the cause and effect of physical interactions. An eye for an eye, a tooth for a tooth. QM is strictly classical, and since QM is Quickian based, then it obviously follows that every equation and concept derived in QM will ultimately be some expression of Euler's formula. And just as Quick rejected Newtonian Leibnizian interpretation of the limit, Quaternion mechanics rejects the theoretical underpinnings of quantum mechanics, which we shall abbreviate as QM. Quantum mechanics is strictly acausal. What's acausal physics? Acausal physics is a field of investigations and computations that are not strictly based upon cause and effect. Quantum mechanics is based upon probability. That is, an eye for an eye 99% of the time, but there is a small chance you may wind up with jello. And just as Quick rejected the Leibnizian concept of infinitesimals, so too does Quaternion mechanics reject acausality and probabilities as the basis of reality. We shall conduct an in-depth comparison of Quaternion mechanics versus quantum mechanics in a future video, but for right now, let's first get acquainted with the basics of Quaternion Mechanics. When first learning Quick, I told you that you didn't have to know anything about calculus in order to learn the rudiments of Quick. And in the same spirit, I'm telling you the same about Quaternion Mechanics. You do not have to know anything about physics in order to learn the rudiments of Quickian physics or Quaternion Mechanics. But once again, what you absolutely must have is a rock-solid grasp of high school trig and especially high school algebra. In Quaternion Mechanics, you will be challenged to manipulate algebraic equations like you have probably never been challenged to manipulate algebraic equations before. And once again, this should come as no surprise to you, since we are basing much of our approach on Baker's book called Quaternions as the Result of Algebraic Operations. Conventionally, physics is defined as follows. Quaternion Mechanics, on the other hand, simply defines physics as the physical manifestation of Euler's formula. Okay, but what does physical mean? Well, for right now, Quaternion Mechanics says physical is anything that can be expressed in terms of one or some product of the four units: mass, charge, length, and time. And for those of you who do have a solid background in physics, I challenge you to find any physical quantity whose units cannot be expressed in terms of one or some combination of these four fundamental units. In Quick, we have demonstrated the primacy of the unit. We have shown that there is no need for any infinitesimals, that it is the unit that is of prime importance in Quick, and that this unit may be of any magnitude we choose. It may be as small as a strand of hair to as large as 1 billion galaxies. And so to exploit this aspect of the unit nature of quaternions, then the mathematical tool of choice in Quaternion Mechanics is dimensional analysis. So what is dimensional analysis? The Quickian explanation of dimensional analysis is not the same as the conventional definition of dimensional analysis. The Quickian execution of dimensional analysis, as opposed to some definition of it, is that in Quick, dimensional analysis simply means that the product of the units on the left-hand side of the equation must match those on the right-hand side of the equation. For instance, if the units on the left side of the equation is equal to mass over time times length, then the units on the right-hand side must also be mass over time times length. This is an immutable rule. It never changes, and it is always obeyed. Always. You may have noticed that I have used Quick and Quaternion Mechanics and dimensional analysis almost interchangeably, and that is because all three are equivalent. At the end of the day, the three units of mass, charge, and length are all versors that obey I equals jk, or alpha beta equals beta over alpha. Time is the fourth dimension, and it is a scalar. Now some of you will immediately say, if the units are to be the same on both sides of the equation, then dimensionally we should have alpha beta equals alpha beta, not alpha beta equals beta over alpha. Again, in Quaternion Mechanics, if the equation is true, then the dimensions always match on both sides of the equation. Always. So let's test this. Alpha beta equals beta over alpha. Therefore, alpha beta equals beta over alpha is equal to beta times minus alpha, which is equal to minus beta alpha. Therefore, alpha beta equals minus beta alpha. Since the rules of Quaternion state that AB equals minus BA, then alpha beta equals minus beta alpha equals alpha beta. Therefore, alpha beta equals beta over alpha. You will find that many conventional physicists will tell you that Newtonian calculus is the mathematics of physics, that it seems almost as if nature invented calculus specifically for physics. And Quaternion Mechanics couldn't agree more with this observation. Again, Quick has no issues with the standard rules of Newtonian physics. Quick only takes exception to some of its theoretical underpinnings. And in Quick, calculus is seen to manifest itself in the form of dimensional analysis. It is the tool of choice since all unit quaternions are just that, units. It is so tempting to approach physics as just a purely algebraic endeavor of unit manipulation. And quite frankly, if you followed this route, you could be quite successful. But if you do that, then you would never experience the physics. Physics isn't just a bunch of numbers being pushed around on a sheet of paper to get the correct answer on an exam. Physics lives, it breathes, it moves, it processes. It is sentient and has agency and purpose and intention. It is an overpowering entity, and that imposing entity is known to us as nature. On the other hand, we can dream and wonder all day and night over the wonders of nature. But without mathematics, we will never be able to come to grips with how or why nature functions as she does. We may ask, does math express physics, or does the physics express the math? In Quaternion Mechanics, the answer is always that the math expresses the physics, and we shall prove that in due course. I have just given you this long-winded, drawn-out speech about how following a strictly dimensional approach will have you missing out on the physics. And yet, despite that speech, for most of this course, that is precisely what we are going to do. You can't really get an idea of the physics until you get in a lab, or play a sport, or drive a car, or shoot some pool, or build a dam, or figure out why there is light from a light bulb, or shoot a rocket to the moon, or, well, you get the picture. You need to conduct experiments. To get to know the physics, you have to observe something, making something, do something, to something, and then try to figure out how and why it did it using the dimensional analysis. But since we can't conduct any observations or experiments in these videos, I'm going to teach Quaternion Mechanics almost strictly using the following model. As goes the dimensions, so too must go the physics. By following this model, you will always get the correct physical result. The problem is you might not know what it is, or why it is, or how it functions, but the physics will nonetheless be there. Another problem with dimensional analysis is that it cannot compute or predict constants. All of these alternative equations are all perfectly justifiable algebraically and quick. But the question is, do such algebraic expressions express a physical reality? Is there some physical analog to these algebraic equations? And to that question I will answer with an unequivocal, resounding yes. Again, I repeat, as goes the dimensions, so too must go the physics. The rules of quaternions coupled with dimensional analysis forces us into conclusions that must be true even though our knowledge of the physics behind the equation might be severely limited. Check out a few of DrPhysicsA videos on YouTube. He is a master of this algebraic manipulation, even though he doesn't call it dimensional analysis or Quaternion mechanics. Links are in the description below. Lastly, it should go without saying that physicists do not like this approach to physics. Most don't get the algebraic connection, and many dismiss it simply because it doesn't execute physics in a conventional manner. Chemists have little use or appreciation of dimensional analysis outside of maybe balancing a few chemical equations every now and then. However, thankfully, most engineers will at least get the concept. They should have no problem following the algebraic pathways. Quaternion mechanics is still, nonetheless, based upon quaternions, and in dealing with quaternions, we all know how insanely confusing they can be. So it's crucial that we establish some lifelines so that when you become confused and lost, and you will become confused and lost, then you can always go back to one of these lifelines, get your bearings, and try again. These lifelines are simple principles that always remain true in Quaternion mechanics. There is absolutely nothing that we do in Quaternion mechanics that cannot be traced back to Euler's formula. Nothing. It is the end-all and be-all of Quaternion mechanics. This Euler's formula diagram is one of the two most important diagrams in all of physics. That's right, even more fundamental than the periodic chart or the genetic code. The Euler's formula chart diagrams the relationships of the various phases of Euler's formula to one another in the two-dimensional complex plane. The IJK precessional diagram is perhaps the most important illustration in all of physics. anything that moves, or doesn't move for that matter, within or upon the four-dimensional plus or minus 1 unit spheres must obey some aspect of this chart. This diagram is found in Arnold and Maunder's book, Gyrodynamics and its Engineering Applications. I strongly suggest you go to Google Books and download the first chapter, which is where the diagram is found. If your algebra has been performed correctly, then it will and must be some viable expression of the physics. This is called dimensional homogeneity. If your equation is dimensionally homogeneous, then the physics must be correct. On the other hand, if your equation is dimensionally inhomogeneous, then it's wrong. These are your 5 lifelines of Quaternion Mechanics. Embrace them, hold on tight to them, and let them guide you to a safe, logical harbor. Now that we are safely secured to our lifelines, we are going to tackle one of the most long-standing problems in physics, the holy grail of physics. We are going to unify gravity with electromagnetism, and we are going to do this by using a strictly dimensional analysis approach. Now, what do I mean by unify? Well, when I say unify or unification, I mean we are going to begin with one general equation, and from that one general equation, we will derive a series of connected equations, with every equation ultimately being connected to any of the other equations in the series. But before I complete this unification proof, first I have to do a bit of house cleaning. Physics and electrodynamics each have their own set of units. Even the relativists have their own set of units. It is all one big disjointed mess. But it is a mess that we will just have to deal with if we are going to interact with the rest of the academic and physics world. Here's a listing of units expressed in a variety of systems provided by Dollard. I have also provided several expressions. The differences in expressions become immediately apparent. You see that several different systems have the same symbol representing the same quantity. For instance, E could be energy or the electrical gradient, or D could be the electrical gradient or distance, or Q could be action or charge or an electron, or E could be Euler's constant or an electron or voltage, or psi could be charge or the wave function, or I could be the current or the square root of -1. This is annoying and confusing, but at least it can be dealt with and eventually sorted out. The fatal flaw, however, is that sometimes we may encounter instances when one system of units is not dimensionally homogeneous with another system's set of units. Dimensional inhomogeneity is a deal breaker. We must either discard the equation completely or find the source of the discrepancy and correct it. What I have purposely done is jump from system to system using units interchangeably. I have tried as best I could to indicate what symbol is being used for what physical quantity. Yes, it would have been much simpler for me to stick with just one system of units. However, contemporary physics just isn't constructed that way. To take full advantage of the fungibility of quick and dimensional analysis, you must be able to float from one system to another seamlessly. To become proficient in dimensional algebraic manipulation, you simply must be able to manipulate any set of units that come your way. Without the fluency in algebraic manipulation, your grasp of both the mathematics and physics will suffer, and you will become hopelessly lost. Having addressed the units problem, let's now unify gravity and electromagnetism. Again, I can't stress strongly enough, this is strictly a dimensional analysis. You do not have to know what any of the variables do physically. You need only algebraically manipulate them correctly at this stage. We will explore the physics of our dimensional equations later in the video. For this particular analysis, we will be using the following variables of physics. Consider the following proof. What we are going to do is take this equation called Cruze law and prove that it is equivalent to this other equation called Coulomb's law. Now, let's just follow the algebra. Now, from the list of the units that I provided, we see that V equals IR, where V is volts, I is amps, and R is ohms. Therefore, voltage is equal to energy over charge. Therefore, energy over charge is equal to the current times the resistance. And the current is equal to charge per time. Therefore, energy is equal to charge squared times the resistance over time. Now, energy is also equal to force times distance. Therefore, force times distance is equal to charge squared times the resistance over time. Dividing both sides by R, we get force is equal to charge squared times the resistance all over time times distance. Now, velocity is equal to distance over time. Therefore, time is equal to distance over velocity. Therefore, substituting time with distance over velocity yields force is equal to charge squared times the resistance times the velocity over the distance squared. Coulomb's law is expressed as force is equal to charge squared times Coulomb's constant over the distance squared. If force equals charge squared times the quantity resistance times velocity all over r squared is to equal Coulomb's law, then it must be the case that Coulomb's constant is equal to the resistance times the velocity. Now, the law of dimension states that if A, B, C equals E, F, G, and A, B, C, E, and G are all constants, then it must be the case that F is also a constant. If Coulomb's constant K equals resistance times velocity, and the velocity is the speed of light, then by the law of dimensions, R must also be a constant. Therefore, we can express Coulomb's constant as the resistance times the speed of light, and this resistance is called Cruze constant, and Cruze constant has a value of 30 ohms. Therefore, the equation force is equal to charge squared times the resistance times the speed of light all over the distance squared is called Cruze law, where the quantity resistance times the speed of light equals Coulomb's constant. Therefore, Cruze law is equivalent to Coulomb's law. Again, at this time, it isn't necessary that you know what Coulomb's law and Cruze law means physically. At this time, all you need to do is confirm that the algebra was performed correctly and that the product of the dimensions on the left-hand side of the equation are the same as the product of the dimensions on the right-hand side of the equation. I will leave it to you to make that dimensional homogeneity check. Once you have satisfied yourself that the final equation is indeed dimensionally homogeneous, then continue on to the next algebraic derivation. And that next derivation is as follows. Planck's constant is given as h. H equals angular momentum. Angular momentum is equal to the energy times time. Energy is equal to angular momentum over time, which equals angular momentum times the frequency. The frequency is equal to energy over angular momentum. The frequency is equal to 1 over time. Energy over angular momentum is equal to 1 over time. It is given force is equal to mass times acceleration. Acceleration is equal to velocity over time, which is equal to the speed of light over time. Force is equal to the quantity mass times the speed of light times energy all over the angular momentum. Force times distance is equal to energy. Therefore, force times distance is equal to mass times the speed of light times energy all over the angular momentum times the distance. Energy equals mass times the speed of light squared. Therefore, force is equal to mass squared times the speed of light cubed all over the angular momentum. This equation is called Schurl's law. Once again, confirm that the dimensions are correct. A standard equation of physics is Newton's second law, where force equals mass times acceleration. Acceleration can also be represented by the constant called g. Now, once again, by the law of dimensions, if c, h, and g, that is the speed of light, angular momentum, and acceleration, are all constants of nature, then in this equation, mass may be a constant of nature. Okay, but what does that mean? It means that in nature, there are fundamental base unit particles of mass. Okay, let's continue to the next derivation. Newton's gravitational force law is given as m sub 1 times m sub 2 all over the distance squared times the constant g. Now again, at this time, you do not have to know what Newton's gravitational force law means. Just know that it is the definitive equation of physics that defines the forces of gravity that exist between any two masses. G is a constant called Newton's gravitational force law constant. We can also express Scherl's law as force equals m sub 1 times m sub 2 times the speed of light cubed all over Planck's constant. Now, the distance squared over the distance squared equals 1. Therefore, we can factor Scherl's law by 1. This gives us force is equal to m sub 1 times m sub 2 times the speed of light cubed all over Planck's constant times the distance squared over the distance squared. This yields force is equal to mass sub 1 times mass sub 2 over the distance squared times the speed of light cubed times r sub g squared over Planck's constant. This version of Scherl's law can be made to equal Newton's gravitational force law if we can show that c cubed times r sub g squared over Planck's constant is equal to Newton's gravitational force law constant g. Now if c and h and g are all constants of nature, then r sub g must also be a constant of nature. Again, this means that there must exist some fundamental base unit of distance in nature. Therefore, force is equal to mass sub 1 times mass sub 2 over the distance squared times the speed of light cubed times r sub g squared over Planck's constant equals Newton's gravitational force law. Now, if you are satisfied that all the units are dimensionally homogeneous, then congratulations. You have now unified the forces of electromagnetism with the forces of gravity. The unification has now been rigorously confirmed, which makes the unification algebraically irrefutable. Now, of course, many of you are saying, wait a minute. You started out with some voltage equation that had charge in it, and somehow, miraculously, you wound up with a force equation of mass. How and where did you make this unseen leap from charge to mass? How could you possibly link the two? Well, the answer is simple. We made the transition from charge to mass when Planck's constant, h, was introduced into the calculations. Let's explore this introduction of Planck's constant in greater detail. We started out with this law called Ohm's law, where the voltage was equal to the current times the resistance. And from Ohm's law, we derived three other laws of force: Coulomb's law, Cruze law, and Newton's gravitational force law. Now, for those of you having little or no familiarity with these laws, then you can only confirm that the algebraic derivations that derive these laws were carried out properly and that all the equations were dimensionally homogeneous. And that was all the skill and information that you needed for this initial step. Now, for the next step, we are going to carry out the unification of Cruze law and Newton's gravitational force law. We are going to do this because even though we have already demonstrated that we can unify Cruze law and Newton's gravitational force law through Ohm's law, I know there are still a host of questions that still remain about what, if any, direct connection exists between these equations. So let's directly unify Cruze law and Newton's gravitational force law. But before we do that, let me first point out that Scherl's law, Cruze constant r, and the constant r sub g are all strictly discoveries based upon theories found in my earlier books, the gyroscopic force theory and gyroelectrodynamics. Quaternion Mechanics and Quick are but refined versions of theories found in these two books. Scherl's law and Cruze law are not conventional laws of physics. However, we have proven both do and must exist. In fact, we have proven that Cruze law is equivalent to Coulomb's law, which is definitely a law of conventional physics. Cruze law is simply Coulomb's law, where the Coulomb's constant has been deconstructed into its two fundamental components, the resistance R and the speed of light c. And by the law of dimensions, another common sense law of my discovery, then if c, h, and g are all constants of nature, then R sub g must also be a constant of nature. Now let's unify Cruze law, which is equivalent to Coulomb's law, with Newton's gravitational force law. Cruze law is given as force equals charge squared times the resistance times the speed of light all over the distance squared, where the quantity resistance times the speed of light equals Coulomb's constant. We may express Sherrill's law as force is equal to mass squared times the speed of light cubed over the angular momentum, which is also equal to the charge squared times the resistance times the speed of light all over the distance squared. Dividing all sides by c of r squared yields Mady's law, where mass times the speed of light times distance is equal to Planck's constant is equal to charge squared times Cruze constant. Therefore, we obtain the following equation. Therefore, we attain the following equation of force unification. Therefore, Cruze law is equivalent to Newton's gravitational force law. And from this simple six-step proof, we indirectly derive Mady's law. And we see from Mady's law that Planck's constant allows us to seamlessly transition from mass to charge, which allows us to smoothly transition from Ohm's law to Cruze law to Newton's gravitational force law. Now, even though you may not know what Ohm's law is physically, just know that Ohm's law is one of the fundamental laws of electromagnetism. And even though we have derived Newton's gravitational force law and Newton's gravitational force constant g from it, when we take a good look at it, Ohm's law still appears to be inhomogeneous. Even though Ohm's law has units of charge, it still doesn't seem to have any units of mass or even units of magnetism for that matter. So how could Ohm's law be a fundamental law of gravity, let alone electromagnetism, since it lacks the magnetism part? And how could gravity and magnetism and electricity all be connected? How could these derivations possibly be correct? These are all good questions, and they will be answered in due course. Now, if you have gotten this far, then you have confirmed for yourself that all the algebra is indeed correct, and all the equations are dimensionally homogeneous, even though logically it may seem like they are not. Therefore, somehow, some way, the physics is correct. Let's further clarify why this is the case. In this third step, I will now introduce one of the electromagnetic theories of Steinmetz, Heaviside, and Dollard. They have provided us with one of the seminal equations of electromagnetism. This simple fundamental algebraic equation of electromagnetism is given as Q equals phi psi. Q is Planck's constant, or angular momentum, where Q is equal to h. Phi is the magnetic flux, where flux is equal to h over q, and psi is equal to charge, where psi is equal to q. This may be alternatively expressed as q, which is equal to Planck's constant, which is equal to the angular momentum, which is equal to charge squared times the resistance, which is equal to the magnetic flux times the charge. This is an expanded version of Mady's law, which once again establishes that Mady's law provides us with a linkage between all three elements of gravity, electrostatics, and magnetism, where mass, charge, and magnetic flux are all three linked respectively. Therefore, given Cruze law is equivalent to Newton's gravitational force law, then using the expanded version of Mady's law, we can unify the two equations, yielding the following unification equations. A fundamental equation of force unification, a fundamental equation of angular momentum unification, and the fundamental equation of voltage unification. where Cruze constant times the speed of light is equal to Coulomb's constant, where R is equal to Cruze constant, which has a value of 30 ohms, and C is equal to the speed of light, and G is equal to Newton's gravitational force constant. What we needed to satisfy any lingering doubts was one single equation that displayed the fundamental units of mass, charge, and magnetism. An equation where we can readily see the various elements that go into forming our various equations. And from such a fundamental equation, we can then derive the fundamental forces of nature and therefore obtain their unification. And so for our final seminal equation of unification, we once again return to Ohm's law, where we obtain the following equation. Therefore, we can rewrite our force unification law as follows. Now, up to this point, I have avoided discussing the physics implied by these equations and concentrated almost exclusively on the algebraic aspects of their derivations. Now, why have I done this? I did this to drive home a point. The algebra always prevails. As I stated in the beginning of the video, it is the algebra that drives the system. The physics tail never wags the algebraic dog. It is the algebra that is the prime mover, and that algebra is the algebra of quaternions. Let's put this assertion to the test. In classical physics, mass, charge, length, and time may all be considered as vectors or scalars. In quick and quaternion mechanics, a quaternion is defined as either a vector or a scalar or a combination of the two. Therefore, mass, charge, length, and time are all quaternions. And since mass, charge, length, and time may describe any and all physical properties or interactions in physics, then by this equation, the speed of light, Planck's constant, magnetic flux, charge, voltage, force, resistance, amperage, time, and mass are all quaternions. And if mass, charge, length, and time are all quaternions, then all the dimensions of physics may be expressed in terms of quaternions. And if all the dimensions of physics may be expressed in terms of quaternions, then the whole of physics must be expressed in terms of quaternions. And if such is the case, then all of physics must be expressed in terms of Euler's formula. Therefore, the existence and applicability of Quaternion Mechanics. Now recall the name of Baker's book, Quaternions as the Result of Algebraic Operations. The title of his book essentially says that we may study the behavior and characteristics of quaternions, and thereby the physics expressed through quaternions by studying only their algebraic interactions, which means the physical function of a quaternion cannot be divorced from the algebra that defines it, which brings us back full circle. As goes the algebra, so too must go the physics. Having firmly established the algebraic utility of quaternion mechanics, we are now ready to discuss the physics of those force equations we previously derived. Now, what is mass? I won't attempt to tell you what mass is, but I will tell you what mass does. Mass attracts or repels other masses. What's charge? Charge attracts or repels other charges. What's magnetism? Magnetism is a property of magnets, and magnets attract or repel other magnets. The attraction of mass to mass, or charge to charge, or magnet to magnet is called a force. A force attracts or repels. A force either pushes or pulls. When a force acts on a mass or a charge or a magnet, then that mass or charge or magnet is accelerated. Therefore, a force exists between any two masses or any two charges or any two magnets. What's acceleration? Acceleration is when a mass or charge or magnet speeds up. Deceleration is when a mass or charge or magnet slows down. Acceleration is a change or increase in velocity. Deceleration is a change or decrease in velocity. What's velocity? Velocity is a vector that measures the amount of distance covered in a certain amount of time. What's speed? Speed is a scalar that measures the amount of distance covered in a certain amount of time. What's a vector? A vector is a quaternion that is generally found along the I-sign or y-axis. What's a scalar? A scalar is a quaternion that is generally found along the cosine or x-axis. What's a versor? A versor is generally a quaternion found along the circumference. A versor is radian. Scalars and vectors are radial. Newton's second law provides us with a nice compact algebraic expression of force, F equals ma. It is one of the most famous equations in all of classical physics. Now why is that? Because as we have proven, using a force equation coupled with Mady's law, you can derive just about any physical quantity in physics. Newton's second law says that we can measure the force acting on a mass by measuring the degree to which the mass is accelerating. And all the ways that force may act is completely and compactly packaged in the precessional chart. This is why this chart is the most important chart in all of physics. In establishing quick, we operated almost exclusively within the complex plane of the plus or minus 1 unit spheres. Since everything in Quaternion Mechanics is based upon Euler's formula, then it should come as no surprise that we may express the equations of force existing between two masses or two charges or two magnets in a scalar or cosine form. That is, we may express each equation as it is expressed along the x-axis as opposed to being expressed along the y-axis or along the circumference. The scalar forces existing between two masses or two charges or two magnets is given by the following equations. Newton's gravitational force law, which is the force between two masses, which lies along the cotangent. Cruze law, which is the force between two charges and resides along the cosine. Maxwell's magnetostatic force law, which is the force between two magnets, which resides along the versine. Their constants may be expressed as follows. What we immediately see is that these equations are essentially the same equation. You can exchange any set of particles with any other set of particles. Just plug in the appropriate constant. If these equations are truly representative of the quaternion equation gamma is equal to alpha beta, which is equivalent to beta over alpha, then we may ratio the three constants, Newton's gravitational force constant, Cruze constant, and Maxwell's magnetostatic force constant. And much to our pleasure and surprise, we see that by ratioing Coulomb's constant to Maxwell's magnetostatic force constant, we derive the quaternion called the speed of light, c, which is a fundamental constant of nature. Note that c is called the speed of light and not the velocity of light because the quaternion operates along the x-axis and therefore is a scalar. And as surprising as this derivation may be, the biggest take-home message of this derivation is this. The speed of light is not just a speed, or an indication of how fast a particle is traveling along the x-axis. C is a particle in its own right. It is an entity, a quaternion, a quantum of stuff that always travels at the speed of light. That stuff has conventionally been called a photon, and quanta of that stuff has conventionally been called light or electromagnetic radiation. Quaternion mechanics finds that just as direction is a quaternion, so too is speed, particularly the speed of light. Notice that in the previous derivations we derived the square root of force. The ratio, gamma sub GE, is a ratio of constants, and in this case, all of the units must be just that, units. Therefore, the square root of force can exist if, and only if, it is a unit of nature. But conventionally, the square root of newtons, or the square root of force, is seldom if ever used as an independent unit of nature. However, as a square root quantity, it may act as a Gaussian integer, or more precisely as a Gaussian unit. Recall that Gaussian integers behave similarly to integers of the square root of n squared type, so we can at least justify its appearance. But physically, what is it? Well, there is one unit of nature that is commonly used when examining the dynamics of tornadoes and eddy currents and that unit is called vorticity. Vorticity is defined as the square root of entropy. What's entropy? Entropy is energy per volume, which is algebraically equivalent to pressure, which is force per area. It has been stated ad nauseum that quick and Quaternion mechanics operate within or upon the plus or minus 1 unit spheres. Somehow, some way, we must incorporate the volume of these spheres into our physics. Observe the following derivation of vorticity. We therefore see that the square root of force is vorticity times distance, with vorticity and distance now being familiar unit quantities. This therefore yields the following equations. Notice, however, that in this equation, we have derived a force constant that includes vorticity as a fundamental unit of nature. Therefore, we have derived two scalar force unification equations, one being this equation, and the other being this equation. Therefore, we obtain that vorticity is equal to the square root of force times mass times the speed of light over phi psi. This yields the following equation of force. This equation is called Johnson's enstrophitic equation of force unification. It is from this equation that we may derive any equation of force in any of the 4 dimensions of the plus or minus 1 unit spheres. Let's put this assertion to the test. Let's derive Newton's second law. Let's derive Coulomb's law. From Johnson's fundamental equation of force unification, we may now list the final 6 fundamental quantities of nature: mass, charge, magnetic flux, vorticity, frequency, and distance. And from these quantities, we may now list the 4 types of scalar forces found in nature: Newton's gravitational force law, which lies along the cotangent; Cruze law, which lies along the cosine; Maxwell's magnetostatic force law, which lies along the versine; and Johnson's law of vorticity, which lies along the secant. And their constants may be expressed as follows. We have derived 2 equations of electromagnetism and gravity unification: the Quaternion Mechanics version of Ohm's law and Johnson's law of vorticity. We have designated phi, the Weber, as being the fundamental base unit of magnetism. So in our 4 force equations, if m is a collection of the fundamental units of mass, which is the kilogram, and q is a collection of the fundamental units of charge, which is the Coulomb, then p should be a collection of the fundamental units of magnetism, which is the Weber. Note, however, that the units of the Weber is angular momentum per charge. Let's take a closer look at Maxwell's law of magnetostatics constant. In Maxwell's magnetic constant, the units of force is expressed in newtons, designated by N. If Maxwell's constant is true, then given Maxwell's law of magnetostatics, it follows that P cannot be phi in Webers if we are to maintain dimensional homogeneity. If Maxwell's constant is indeed true and is to remain unchanged, then the following equation must be true. Conventionally, the quantity QR equals psi r is called the electric dipole moment. Therefore, we may rewrite Maxwell's law of magnetostatics as follows. We must then ask, If P equals IR is a fundamental particle of nature, then why isn't it included in Johnson's law of vorticity? Well, the answer turns out to be it is included. The following equation proves that this is indeed the case. When a moving charge is subjected to a perpendicularly applied magnetic field, the magnetic field exerts a centripetal force on the charge, forcing the charge to orbit in a circle. The equation that describes this force is called the Lorentz Force. The Lorentz Force is a cross product. What's a cross product? A cross product is the product of two orthogonal Lavoisian conjugates. The cross product is generally indicated by the product sign. The Lorentz force is defined by the following cross product. The electrical gradient is equal to charge times velocity times the magnetic field. Now, what does this all mean? Let's take a look at the unit circle. Imagine that the point where the sign intercepts the x-axis is the moving charge, and that the sign itself is the perpendicularly applied magnetic field. The charge is being pulled toward the center, so it's being acted upon by a centripetal force per charge along the versine. If the charge were moving away from the center, along the cosine, then it would be pushed away by a centrifugal force per charge. Force per charge is the electrical gradient. By definition, a moving charge is defined as being a current. Now, since the original charge is moving, then this original moving charge forms a current. So the current I is equal to charge over time. And so the Lorentz force says that the force per charge being equal to the current measured over some distance times the perpendicularly applied magnetic field B will force the moving charge of the current to revolve about in a circle. And if we look closely at what is happening to the sign, we see that is precisely what occurs. The intersection of the sign and the x-axis is the moving charge. The versine is the distance. The sign is the perpendicularly applied magnetic field. And the intersection of the sign and circumference is the moving charge revolving about in a circle. So trigonometrically, we could say that the quantity of the current times the versine along the x-axis times the sign along the y-axis is equal to the electrical gradient E. Therefore, the electrical gradient E is equal to the cross product of the charge times velocity times the perpendicularly applied magnetic field. And so therefore force is equal to the cross product of the charge squared times velocity times the perpendicularly applied magnetic field. Dividing both sides by the area, we obtain the quantity entropy. But Cruze law provides us with a similar equation that may be expressed as a dot product as given by the following equation. Okay, but what's a dot product? A dot product is the product of two vectors or scalars that lie along the same coordinate. Generally, it means the product of two linear conjugates that lie along the x-axis and is indicated by the dot. So the dot products are generally x dot x and cross products are x times y. There are no orthogonal dot products and no parallel cross products. All dot products occur between parallel elements, and all cross products occur between orthogonal elements. So we can reconvert the entropy equation to one of force by factoring it by the area. This yields the following equation. But the magnetic flux phi is defined as the magnetic field times the area cosine theta. Therefore, force is equal to the dot product of the quantity charge squared times velocity all over the area dot the magnetic flux. Therefore, Cruze law and this modified version of the Lorentz force are equivalent. Therefore, Cruze constant R and phi the magnetic flux are equivalent. Therefore, the resistance R resists the flow of the magnetic flux phi. Since both equations are scalar and found along the x-axis, then the electrostatic centrifugal force of Cruze law is found along the cosine, and the magnetostatic centripetal force of this scalar version of the Lorentz force is found along the versine. Therefore, the Quaternion mechanical interpretation of the magnetic flux is given as follows. The magnetic flux is the dot product of the magnetic field, dot the area versine theta, which is equivalent to the negative resistance. All of these equations combine to generate a family of dot products and cross products. It must be stressed that these dot product and cross product equations are not forces due to static charges. They are forces that are due to a moving charge or a changing field being applied to a charge. Therefore, Cruze law is not the same as its dot product, even though both are scalar forces. This dot product of Cruze law is called Maxwell's displacement current. The resistance of Cruze law is radial and a scalar. The resistance of its dot product is also radial, but vector. The resistance of its cross product is radian and a vector in the sense that it is the conjugate of a scalar. In the displacement current, the electron follows a straight line radial path. In the Lorentz force, the electron follows a curved radian path. We have thoroughly and exhaustively unified gravity and static electricity through dimensional analysis and the principles of Quaternion Mechanics and the gyroscopic force theory. However, I have no doubt that there are still some of you who still remain unconvinced. So in a final attempt to remove all doubt, I'm going to apply a more rigorous alternative approach to mathematically unifying gravity and electromagnetism. And I'll do this by deriving Newton's gravitational force law and Newton's gravitational force constant G using the magnetic moment mu. Consider the following proof. Now, I will leave it to you to study this entire proof at your leisure, but for now we must address some of the major points of this proof. Michael's law is a consolidation of both gravity and inertia. Newton's gravitational force constant G may be expressed as Daniel's constant. The gyro-magneto ratio is given as follows. Coulomb's constant is Cruze constant times the speed of light. Sigma is equal to a dimensionless constant and is called Tracy's constant. Since the vorticity squared equals entropy, then Michael's law incorporates the 6 fundamental units of nature: mass, charge, length, frequency, magnetic flux, and vorticity. By converting Newton's gravitational force constant, G, into Daniel's constant, Michael's law is therefore converted to a unification force. Therefore, Michael's law is equivalent to Johnson's astrophysics equation of force unification. We may unify the force constants under Arberry's law. Arberry's law is given as follows. Arberry's law allows us to seamlessly compute any of the 4 scalar forces laws in conjunction with the inverse square law. And there you have it. Michael's law unifies the forces of gravity and electromagnetism.